Hey guys, welcome to the Quantity Surveying Studio. This is going to be a quick video telling you the importance of equipment schedule. Let's imagine a room. So there are a lot of AC indoor units. You've only been given a layout. There is no equipment schedule. Imagine that is a situation, and it is showing let's say there are 5 number of ACs, and it is having the legend of symbols shows that a square with a cross is an AC. So that is being shown. So 5 numbers of AC, you do a quantification, and in your BOQ you put up that there are AC indoor units, 5 numbers. But the problem here is you don't know about the capacity. You don't know if all the ACs are of same type of capacity, the same size. So what an equipment schedule can give you is the specifications of all these 5 ACs. When you are provided with a equipment specification, you get to know that AC number 1 is having this much of capacity, and this is the size, this is the manufacturer. AC 2 is like this. So you can put your BOQ separately. Sometimes 2 ACs might be of same type and all the specs might be same. For another 2 ACs, it might be something else, and 1 AC can be something else. So pricing can be done according to that specifications. And if you're not provided with an equipment specification like equipment schedules, please make it a note to send a query regarding the equipment schedule. That is very, very important for a MEP quantity surveyor, without which you will not be able to understand the capacity of different equipments, and you will never be able to price them properly. As you go through documents while doing your quantification, this should be one of the most important documents that should be available, and if it is not available, raise the query. So thanks a lot for watching this short video. So please do like this video if you found it to be useful. Do subscribe if you're not yet subscribed to Quantity Surveying Studio. Take care. Bye. Hi all. Welcome to the Quantity Surveying Studio. Hope all are doing good, having a great time in your career. So this video is gonna be related to CostX and especially something related to zoning. So what zoning is, you will understand from this video. So I've just uploaded a drawing here, a sample drawing, just few MEP fixtures being shown. In this example, I'm going to take out quantity of fans. So what we usually do is go to dimensions, add dimensions. So we're giving a folder called MEP and a name called fan. So it's a count measurement. And we insert this dimension group, and we are counting it. 5, 6. So we have 6 numbers of fans, and here in the workbook, so we are counting, we have 6 numbers. We're dragging the quantity. Okay. The client requirement is that they need the quantities separately for halls and bedrooms. So if you see, you have fans in hall, here are fans in the bedrooms. So that is the requirement. So for that requirement, what we do is zoning. So for that, if you go to dimensions, there is something called edit zones. So click on that. Now here what we are going to do is make zones. So insert. So one is zone category 1. The zone name we can give as, let's say, hall. We give the description as fan in hall. So we insert that. Now we make one more for the bedrooms. Insert. We give it zone category 2. Give the name as bedroom. So fans in bedroom. Insert it. So we have zone category 1 for hall and zone category 2 for bedrooms. We update it. Now what we do is we have to split these quantities into different zones. So for that, what we can do is, for example, this is in hall. This is in bedroom, this is in hall, this is in hall, this is in bedroom, this is bedroom. So go to this one. Since it is in hall, go to modify dimensions. There is change zone. We click on zone category 1 hall. Click OK. This is one bedroom. So we click here, modify dimension, change zone. Since it is in bedroom, is it zone category 2? Okay. Now this is in hall, this is in hall. So this is, we change it to modify dimension, change zone, hall. This is also hall. Modify dimension, change zone, hall. Now these two are bedrooms, so we can both select together. Right click, modify dimension, change zone, zone category to bedroom. Okay. So now what we can do is split. So fan in bedroom and fan in hall. So now when we drag the quantity for bedroom, what we can do is, since it is zone category 2, click on bedroom here, click here like this, select that only and update. So if you see here, 3 numbers came. Similarly for halls, after dragging the quantity, just click zone category 1. Since halt is inside zone category 1, selected, update. So now we've got a split quantity. We have the total, it was 6 numbers initially what we have done, and now we have the split quantity, 3 numbers in bedroom and 3 numbers in hall. So this is the purpose of zoning. So maybe in a project there might be different phases in the same floor, there might be room wise, there might be requirements. So for that purpose zoning is used. So hope this video was informative. Thanks a lot for watching this video, and there are a lot of other CostX related videos that I've put. So keep learning. Thanks. Bye. Hi, welcome to the Conti Surveying Studio. This video I'll be explaining something regarding NRM2, and that too particularly the 39 section, which is for electrical services. So in this section, if you have used it, you would have experienced this, or else if you're gonna use it, maybe this video will be useful to you. So if you see, there are subsections like cables, and there is also a subsection called final circuits. You see, the unit of measurement for cables is meter, and for final circuit it is in numbers. So what is the difference between these two? So this is some confusion that happens when you make your BOQ, like what to put here, which items to put here. So to explain that, let's move into a whiteboard. So just rub whatever is here. Okay, so let's say that you are having, your project. So it is a maybe one floor. You're having a building, one floor building, ground floor only. Let's assume. Okay, so maybe there is a small substation, and the main power is coming. So main power is usually maintained by the government. Some electricity boards might be there. So from that, it is going. The substation will have different equipment like transformers, then the generators, maybe the main distribution board. Let's say the main distribution board is here. So MDB. So from transformers, we have like cables going to MDB. Then there are different other equipments like generators, and then the automatic transfer switch. I'm not going into detail about all those. From MDB, there is, let's say there is an electricity room inside this building where all your DBs are DBs that needs to distribute power to your different equipment, different fixtures inside your building is there. So let's say MDB, then there is a sub main distribution for submain distribution board, and then there are different dBs. So let's say LDB, lighting distribution board, which will be distributing power to the different light fixtures. Then there is a power distribution for the all the sockets and all those fixtures. Now let's say there are different, sorry, just change the color. We have different light fixtures. Then we have also the like power sockets, just giving a random symbol. Now we have cable coming from here to all these equipment, and from the main distribution board a cable will go to the sub-main distribution board. From sub-main distribution, cable will be going to the lighting distribution. One cable will go to the power distribution. There might be different dBs more than what is shown here. So in this particular example, I'm just putting just 2 dBs. Now in this distribution board, like there will be many circuits, and from each circuit it will be giving power to a particular number of lights. So let's give this color. So from lighting distribution board, there will be one circuit will be for these 3 lights. There will be another circuit for these 3 lights. And similarly, for power distribution board, there will be one circuit for these 2 lights. There will be one circuit for these 2 lights. I mean, these 2 power sockets. There will be one for these 2. So in this, what will come under the cable section and what will be coming under the final circuit? So for under the cable section, all these cables that come from the supply board to the substation to the different equipment, and till then the cables that goes from the MDB to SMDB, then from SMDB to LDB, whatever is shown in this brown color, these are all coming under the cable section, which needs to be measured in meters. This one. And all these are usually the blue color, which is for the lighting circuit, and this red color, which is for the power circuits. These are usually in numbers, not in meters, because it is as per the NRM2 for the final circuit, that is wiring or cabling for these fixtures is counted in numbers. So for example, if there are, for here you see 1 2 3 4 5 6 7 number of lights. So if there are 7 lights, the final circuit will be for lighting will be 7 numbers. Power socket 1 2 3 4 5 6 are 7 numbers. So the final circuit for power under the power section will be 7 numbers. So in NRM2, for the final circuit for the lighting, power fixtures, and all other fixtures, the cabling is usually measured in numbers. There will be a unit price for each point. It's called point wiring, and there will be a particular rate for each point wiring, and that is usually used. And for these other cables, the low voltage, it's called low voltage cables, and here the medium voltage cables. So for that, we have to measure in meters, that to cable sizes as per what core it is, what size it is. Maybe it might be a 4 core 185 square meter copper conductor cable. So based on that, we have to differentiate and put the quantities in meters, and for this part it will be in numbers. So hope this small video is informative. So next time when you do your BOQs, you know where to put what, where you have to put the cable sections, what you have to put under the cable section, and what you have to put under the final circuit section. So thanks a lot for watching this video. Hi all, welcome to the Conti Surveying Studio. Thanks a lot for the support being shown to QS Studio. If you have not yet subscribed to this channel, please do subscribe for quantity surveying related videos. Do share about this channel to your friends who are into the QS field. Without further delay, let's move into the video. This video we'll be looking into a section wherein you can make a BOQ while using NRM2 for the renovation or refurbishment works. So maybe in a particular project there would be complete refurbishment work. So how are you going to make a BOQ for that? So to answer that, we have the NRM2 section 4, which is alterations, repairs and conservation. Major kind of works like alteration work to existing buildings, repairs, cleaning, renovation, conserving, decontamination and recycling works comes under this section. So if you see, there are subsections related to these works, like works of alteration, removing, cutting or forming openings, removing existing and replacing, repairing, repointing, cleaning, renovating, conserving. So all these kind of works are included in this section. And the unit of measurements, if you see, there are all the unit of measurements being included, for example, for this section. So you can utilize the best one that suits your design, which is easy for pricing. Based on that, you can easily include that particular unit of measurement. So one thing to note is that only the renovation works are being carried out here. So once, for example, you are removing a few lights, maybe 10 lights, so that will come under section 4, subsection 2. You can put it under here. 10 number of lights are being removed, but then installing new lights instead of these removed ones will come under the normal section, that is the electrical installation section is there. Under that, it will be included in that section. So that you have to be careful that you need to only put those works which is related to the alteration part into this section, section 4, and the other new installation works in the relevant sections. So hope this small video was informative. Next time when you are making a refurbishment BOQ, this section is going to be really helpful. So thanks a lot for watching this video. Take care. Bye. Hey all, welcome to the quantity surveying studio. So hope everyone is doing good, having a great time in your career, in your personal life. It's been some time that I've made video on this channel. I was basically traveling. I was not well. A lot of travels happening for the past 4 or 5 weeks. So I was really busy on the weekends, and then I was not well for almost 2 weeks. Viral fevers and all those stuff. So that was the reason why I was not able to make videos. Now, hopefully, everything is fine and I'll start putting contents. Uh, so, hope everyone is having a good time in your career. So now is the appraisal and promotion time. So, hope everyone is having a right kind of appraisals happening, or something that you have expected is happening. Sometimes it might not be happening also. So don't worry, this is just part of the corporate world. It will just go with the flow. Just move on with the flow. Everything will happen fine. This was a video regarding CostX. I've started a small course on CostX in Udemy, and I'll just put the link to that course in the description. You just click on it, you will be taken to the course. So just the basic course. So what is happening right now, I'll tell you. A lot of companies are outsourcing the works that is happening in their counterpart country, like for example mainly UK, Middle East, and the US. These are the main countries. So I'm also part of that department, wherein I am a part of the UK team. That is a company. Our company has projects happening in the UK, and we as a team here are supporting those people who are sitting in the UK team for different pre-contractual tasks. And right now, many companies are implementing this kind of model. Recently, a very famous MNC, which is based in the UK, they've started recruitment. They require around, I think, 30 plus candidates exclusively for this department that they're going to form, which will be supporting the team which is sitting in UK from India. Because in India, the labor is cheap. We have that good technology knowledge, and definitely using that advantage, they can easily be competitive in their country using our help, our support. For example, it is almost double the charge per hour charge what someone who is sitting in UK is charging when compared to someone who is based in India. So that is kind of attracting the different countries based in these UK, US, Middle East to outsource the works from India. And even if you go into an Indian project, you know how the budget is. You will not be paid that heavily. So one way to start getting a good increment in your next jump is to get into a job, such kind of job, an outsourced service kind of role, where you can really get a great, you can ask for a great percentage increase when you join it. And one advantage, that like one thing that you can add to your CV is that you have a knowledge of COSA, because most of these MNC companies will be using CostX rather than the AutoCAD or anything else. Only the Indian companies will be using mostly AutoCAD. So if you know CostX, then that would be great advantage for you as a candidate. And other than that, all these standard formats, like the standard method of measurements, like NRM, POMI, SESM4, ARM, if you have the knowledge, well and good. If you don't, Just start going through those documents, read through it, get some sample BOQs made using these standard method of measurements, go through it. You can easily understand how BOQ is structured using these method of measurement, because that is really important while working for these international projects. So that is another way. So yeah, so if you want to learn CostX, the basics of CostX, this course is will be getting on, updated slowly. Lot of new modules will be added. So if you just purchase this one time, even when a new module is added, you need not pay your money again. You can easily access it, the new modules, with the initial payment which you have done. So as I've said, I'll be putting it the description of this. The link for this course in the description. Just click on this and get a feel of how CostX looks, and will definitely gonna help in your next job search. So thanks a lot for watching this video. More videos are gonna come now. Hopefully, I'm more well now, and the kind of travels will be limited. So because last 2 months were the vacation time, so my daughter was kind of free, so we had to entertain her, or else she would be bored. Now once June start, the schools will be starting, so the traveling will be limited. So hopefully I'll be able to concentrate more on the videos. So yeah, thanks a lot for watching and supporting this channel. Take care. Bye.
Hey all, welcome to the Conti Surveying Studio. Hope everyone is doing good, having a good time in your professional and personal life. This video is gonna be about some estimation techniques in construction. This is as per the AICEI, and maybe if you are someone who is preparing for your CCP examination, this video is going to be really helpful. So without further delay, let's move into this video. Basically, there are two types of estimation techniques. One is the conceptual estimation method, the other one is the deterministic estimation method. Conceptual is the method used during the early project phase when you don't have much of the details, during the feasibility stage where the design is not available. And the deterministic method is during the detailed design stage when you make the final BOQ, the tender BOQ, where you all have all the design, drawings, specifications, etc. Conceptual estimation technique, there are different methods, and some of them are listed here: the end product unit, physical dimension method, capacity factor, ratio factor method, and parametric modeling. So let's look into each one of these with examples so that it is easily understood by you. So first one is the end product unit method. So this is basically based on the unit. So sometimes you might be constructing a 100 room hotel or 100 bed hospital. So based on the unit, this method is used with the historical data that is available. So if you see the example, so consider an investor who wants to build a 1500 room luxury hotel in a resort area. Investor wants to know the approximate cost for the same. So just to, before starting the project, they just want to know how much it is it going to be costing. So just like a feasibility study. So a similar luxury hotel has been recently completed at a nearby resort, and following info is available. So number of rooms that was constructed was 1000, and the total cost was 67.5 million dollars. Based on this historical data available, for one room it is going to cost around $67,500. So 67.5 million divided by 1000. For one room it will be $67,500. So if you want to construct 1500 room hotel, it is going to be $67,500 into 1500, $101 million, $101.25 million. So this is basically the end product unit method. So based on the units. Next one is the physical dimension method. This is similar to the unit method, but here the physical dimensions are basically used. The historical data of the physical dimension in the historical data is being used. So let's see an example. You want to construct a new warehouse of 3600 meter square, and recently a warehouse of 2900 meter square was completed at a cost of $623,500. So for one square meter, it is going to be costing 623,500 divided by 2,900. So it is $215. So to construct 3,600 meter square, it is going to be 215 into 3,600, which is $774,000 based on the physical dimension method. It can be area, volume, length, all those physical dimensions can be used for whatever previous historical data you have. Next is the capacity factor method. This is basically based on the capacity of the unit or the building that you are being constructing. So this is the formula that is used. C2 is equal to C1 into S2 by S1 into the whole raised to X. C2 is the cost that we are estimating, that is for the new building. C1 is the non-cost, that is for the base building which we already have the data. Again, S2 is the new capacity, the capacity of the building which we need to construct, and S1 is the base capacity which we already know. And there is this capacity factor which is used, and usually 0.5 to 0.85 is used. Mostly it is 0.6. So in between 0.5 and 0.85 is used, and commonly it is 0.6 that is used. So an example, if you see recently completed 200 megawatt project cost. So this is the capacity that is being used here. It was $150 million. What will be the approximate cost of a similar power plant if the capacity is doubled and E is 0.6? So we know that 200 megawatt is a non-cost C1. So C1 is 150,000. Now S1 is the base capacity. So S1 is 200 megawatt. Now S2 is they need to find the cost of a plant which is double. So 200 double is 400 megawatt, and E is given as 0.6. So now we need to find out C2, the cost of this doubled plant. So C2, as per the formula, if we apply, C2 is equal to C1. C2 is equal to 150,000, $150 million into 400 by 200. S2 by S1 all raised to 0.6. So when you do this, you're gonna get the value as 227 million US dollars. This is capacity factor method. You can pause each example for each method and maybe work it out so that you will also have an idea. Next is a ratio or factor method. This is used when you have a plant, big plant, and a huge equipment is used in that plant. So based on that equipment cost, you can calculate the total plant cost. So if you see the formula, total plant cost is equal to the total equipment cost into the equipment factor. So some factors are also used for this method. So there was this guy called Lang who proposed three factors based on the type of the plant. So if it is a solid process plant, 3.1 is the factor used. If it is a solid fluid combined process plant, it is 3.63. And if it is a fluid process plant, it is 4.74. So let's see an example, you'll understand it better. So the total estimated equipment cost for a fluid process plant is 1.5 million US dollars. What is the total plant cost? So you know the equipment cost for that plant, and they are asking you to find the total plant cost. And it is also said it is a fluid process plant. So as per Lang, 4.74 is the factor. So if you see this, if you apply this formula, the total plant cost is equal to total equipment cost into equipment factor. The total equipment cost is $1.5 million and equipment factor is taken as 4.74. So if you multiply it, you will get the total plant cost as 7.11 million US dollars. So based on this equipment cost, you are finding out the total plant cost. Basically used for plant projects, big plants. And the final one is the parametric modeling. So here different types of factors are considered, taken into account, which is very important. If you see the example, calculate the estimate of a house with these details. Size is 200 square meter. We know the cost per square meter as 50,000 US dollars. Then there are some additional factors which we need to consider, which is luxury factor, which is a 20% increase, complexity factor 15% increase. So when you calculate for 200 square meters, when you have 50,000 as per square meter, you will calculate it and will multiply it and find out that it is 10 million US dollars. Now you need to add the luxury factor on top of it. So luxury factor is the 10,000 into 20% increase, so into 1.2. So you'll get 12,000 million US dollars. On top of that, there is something called the complexity factor, which is a 15% increase. So when you include the complexity factor, you will get 12,000 into 1.15, that is 15% increase. You will get 13,800. So the final cost, so initially the base cost was just 10,000 million US dollars, but when you add all these factors, the luxury factors, complexity factors, you'll get the final cost as 13.8 US dollars. This is something called parametric modeling. There can be different types of factors depending upon the type of projects that you're doing. There will be different types of factors, and that you'll get from the historical data. Sometimes you must have done some residential project previously, and all these factors would have come into account. So based on that, your price would have increased. So taking into that account, we are doing a quick analysis of, okay, these factors will also needs to be considered on the top of this base cost. Now we'll look into the deterministic estimation techniques, which is the detailed estimation, which is done in the detailed design tender stage. So the steps are, if you're a QS estimator who is having a few years of experience, you might be knowing all these steps. So first you need to do the project document review, the drawing specification schedule. Then you have to do the takeoff using the different softwares, the make a list of quantities, and that using the different NRM method. You need to calculate the quantities. Then you need to apply the unit rate based on the market situation, then the indirect cost, overhead, preliminaries, risk allowances, then the contingencies based on the risk and uncertainties, then some the escalation or location factor you need to apply, the inflation factors or regional indices. And when you do all this, and again BOQ you need to prepare using the different standards of methods of measurement, and you summarize all elements for getting the total project cost. So that is the basic steps that is being carried out during the detailed design stage. We'll conclude this video. So depending upon the what the project is in which phase and what the data is available, we choose the type of estimation technique. Conceptual, as you already understood, it is a fast high level estimation technique, and deterministic is detailed and an accurate estimation technique. So if you do a good estimation, it will support in the budgeting, proper planning, and decision making of the project. So hope this video was informative. Thanks a lot for watching this video. Take care. Bye.
Hello everyone, welcome back to Quantity Surveying Studio. In this video, we'll explore a very critical topic: why do construction projects face cost overruns? We'll be understanding the root causes, a real world example, and how a QS can help prevent them. So let's see, what is a cost overrun. A cost overrun happens when the actual cost of a project exceeds the budget that was initially approved. So this isn't just a financial issue, it leads to delays, disputes, and in worst cases, project failure. And it is one of the biggest risks in the construction project, and yet it keeps on happening. So these are the top reasons for cost overruns: poor scope definition, design changes or variations, inaccurate cost estimates, procurement delays, inflation and market changes, poor risk management, lack of change control processes. So let's take a closer look at each. Poor scope definition. When the project scope is not clearly defined, it leaves room for interpretation and changes later on. So this leads to a lot of additional works, additional materials, and reworks, all of which will inflate the cost. Design changes or variations. Now, design changes after the project starts are extremely costly. Clients often change the requirement midway, and the contractor is required to adjust. This will increase the cost and the time. So, that's the main reason why freezing the design at an early stage is very critical. Inaccurate estimates. If the BOQ is based on poor data or assumptions, the project starts off with a wrong budget. So, a quantity surveyor must work closely with the designers and use the market data to ensure realistic costing is carried out. Procurement delays. When materials and services are not procured in time, it will cause site delays. Idle labor, rescheduling, and storage issues will also lead to additional expenses. Inflation and market fluctuations. The price for steel, concrete, and MEP items can change quickly, especially in today's volatile markets. So that is why escalation clauses must be included in long duration projects. Poor risk management. Unanticipated risk like weather, labor shortages, or design errors can derail budgets. Good projects have a risk register with identified contingencies, but many skip this step. Lack of change control. Without a formal change control process, variations are implemented without proper approval or cost checks. So, this leads to budget chaos and disputes between client and the contractor. So, this is an example of a real world project, that is a Berlin Brandenburg airport project. So, it faced over 10 years of delays and billions in cost overrun just because of design changes, poor planning, and miscommunication. So, it is a very clear example of how not managing the scope and risk can become a disaster. Now, how a quantity surveyor can help in preventing all these cost overruns? So, first is preparing a detailed and realistic BOQs, then allocating and pricing risk appropriately, implementing proper variation controls, forecasting and reporting cost regularly, being involved early in the design stages. So, these are some practices that can ensure that the surprises in a project are minimized, and hence the cost overruns also will get minimized. So, some final thoughts. Cost overruns are not just like a bad luck, they are often a result of poor planning and lack of control. A skilled QS adds value by forecasting problems before they explode into expensive issues. So, thanks a lot for watching this video. If you found this use helpful and useful, give it a thumbs up and please subscribe to Quantity Surveying Studio. And please comment below if you have faced similar cost overrun challenges and how you handled them. So, see you in the next video. Welcome to the Quantity Surveying Studio. So, in today's video, we'll be exploring a critical yet often overlooked aspect of MEP works, that is, how to size cables correctly. Whether you're a QS or an MEP engineer, understanding cable sizing is very essential for both design accuracy and cost control. So, as a QS, it is not like required to you get into the design aspects, but if you have that understanding, if you have that knowledge, it is a good add-on to your knowledge, and you can also advise to the designers that such and such cable sizes will not be sufficient for such and such type of cables going from this TB to this TB because of such and such reasons. So cable prices will keep on changing with respect to the sizes. So that is really important. So why does cable sizing matter again? As I said, incorrect cable selection can lead to overheating, voltage drop, system failures, and even fire hazards. And for QS, it is crucial because cable sizing will affect both the BOQ quantity and the pricing. Some key parameters for cable sizing. These are load current, voltage drop, short circuit capacity, derating factors, and cable route. I'm not going into deep on the technicalities of these. So just understand that these are the parameters that is used to determine a cable size. These are the step-by-step process for identifying the cable size, and I'll be showing it through an example also. I made a Excel template. So identify the load first, then determine the permissible voltage drop, apply the derating factors, select the cable size from the table, standard tables, check the short circuit ratings, final selection with correct installation. So there are basically some steps that needs to be done. I'll explain it in the Excel template. Some common mistakes that designers make. So these are some using some thumb rules blindly that they see from the net. They just take that as the correct. They don't check if it is right or wrong. Then ignoring the voltage drops for long runs, overlooking derating factors,
not verifying the protection settings. So these are some common mistakes that designers make. Some tools and software that is used to measure, like identify which cable size to be used. So that is ETAP, Ecodial, Caneco. Then the manual Excel sheet is there. The manufacturer's data sheet is there. Usually designers use these softwares. So as per the QS perspective, BOQ specs must align with design. So bigger cables means higher cost. So QS must interface early with the MEP teams. Some final tips will be always to refer to the local codes, use accurate manufacturer data, and plan the cable routings in an early stage. So PPT is over here. I'll just go through the Excel template. So this is a template that I've prepared. So there are different steps here. I have made two sheets for copper cable and aluminum cable. The major difference would be this part, that is the resistance. Based on this, the calculations will be changing. So here first step is to know the load, what the load the cable will be carrying in kilowatt. The voltage, if it is three phase, it is 415 volt. The power factor, which is usually commonly taken as 0.85 to 9, so I've taken it as 0.9. So we have to choose whether it is a single phase or three phase requirement. Here this is neutral and earth requirement. Based on this option, our core will be changing. So here if you see, I have kept it as no, but if you are changing neutral required as yes, automatically the core changes to 3.5. And also if earth is required, it will change to 4. So let's keep it as no for both. Phase multiplier, so if it is 1, it will be 1 for single phase and root 3, that is 1.732 for three phase. Since we have chosen as three phase, I have kept it as 1.732. Then we need to calculate the current. So current is B3 into 1000, though kilowatt into 1000 divided by voltage into power factor into the phase multiplier. So we will get the calculated current. Then the distance that is cable needs to be laid between the different main dB or the distribution dB. Between the two distribution boards, how much is the distance that we need to calculate. 5 is the permissible voltage drop percentage, that is the common practice. Again, derating factor is also taken as 0.85 as per industry standards. Then we need to calculate the adjusted current, which is B10 by B13, that is calculated current by derating factor. So this will be the actual current that needs to be carried by the cable. So we need to see in this table, based on the core, type of the cable and size, what are the different cable, maximum cable amperes, current carrying capacity of each. Based on that only we finalize the sizes, because through this steps we can only determine the minimum cable size. The maximum cable size will depend upon this table, so we'll see that now. So next is, we got it as adjusted current as 181. So this is the main thing that we need to check now. So here we need to keep on changing cable size. So before that, let's see what are this below. Resistance, so this will keep changing. For copper it is 1.91 resistance, and for aluminum it is 3.08. That is the main difference between these two materials. Then we'll to calculate the resistance of selected cable, that will be B16 by B15. So this resistance divided by the selected cable size. Then voltage drop we have to calculate, that will be 2 into B10 calculated current into B11, the distance, into B17, the resistance of the selected cable, divided by 1000. So we'll get the voltage drop, and then finally the voltage drop percentage, which is the voltage drop divided by voltage B4. We need to finally check if this what we have got is less than this permissible. So for example, I'm changing this to, let's say, 4. So after changing this to 4, see, voltage drop is 8.89, which is more than the permissible. So we cannot use 4. Let's check it with 6. Again, it is increasing, 5.93. Then we have to choose the next standard one. Next will be 10 mm square. So when we chose M10, it is fine, 3.56. It is less than 5. Now we need to check. So minimum size that we can use is 10. Now let's understand what is the maximum size, and that is the selected cable size that will be required. So for a 3-core cable, copper cable, what size will carry a current of 181? So for a copper cable, 3-core one, if you see 25 will carry 131 only, 35 square mm will carry only 160, but 50 will carry 201, which is more than 181. So we can choose 3-core 50 as our cable. So 3-core 50 for this purpose is we can use. But if you see in case of aluminum, let's see it as 4, it is more. Let's put it as 6, it is more than 5. Even 10 is also more. So in this case, we can put the next standard cable, which is 16, that is less. So in case of aluminum, for a 3-core cable, for 181, if you see 25 will carry only 164, but 35 can carry 200. So 3-core 35. So for this scenario, if we are choosing copper as the material, it will be the 3-core 50 cable, and if it is aluminum, it will be 3-core 35 cable. So hope this video was informative. Thanks a lot for watching. If you need this Excel sheet, do comment. I can share it with you any of my social media channels, because I'm not sure if your email ID can be commented in the YouTube comments. You can go to LinkedIn, or you can message me in LinkedIn, my Instagram, YouTube channel, Instagram account or Facebook account. Everything is put up in the description, all the links to that. You can go anywhere and just message me. I can share it with you. So please like, share, and subscribe to Quantity Surveying Studio for more practical construction insights. Thanks.
Welcome to Quantity Surveying Studio. So in this video, we'll learn how to wisely include allowance percentages while pricing construction projects. So these are just not numbers. These are like safeguards against uncertainties. So what are the allowance percentages? Allowance percentages are like a buffer sum which is added during estimation. They are like cushions to absorb some uncertainties like design changes, quantity variations, or even site conditions. These are generally applied as a percentage on the base cost or some specific line items. Now we'll see some common allowance categories. So these include the design development allowance, which is usually 2 to 5%. Then we have the construction contingencies, which is around 3 to 10%, especially if design is not complete. Then the estimating contingency, which is 5 to 15% based on the project complexity, size, etc. Then the escalation and inflation allowance, which is around the 2 to 6% range, depending upon again the project duration. Finally, we have the client change allowance or the stakeholder change allowance, which is around 3 to 5% for potential scope changes by the client. So these are few categories for which we need to add an additional percentage on top of our base pricing. Now let's see when to include these allowances. So in early design stages, you must include allowances because the scope is not frozen at that time. So if the drawings are 60% complete, there's a good chance there is something missing. And if the project involves some new technology or regulations, there is a red flag for risk. So allowances are very, very crucial. This is a small sample calculation. So the base cost, let's assume, is around 1 million US dollars. So on top of that, we are adding a design allowance of 5%, which is 50,000 USD. Then a contingency, which is around 10% of the base cost, which is 100,000 US dollars. Then an escalation of 3%, which is around 30,000. So when we add all these allowances to the base cost, it will come around to 1.18 million US dollars. So this will finally become your project pricing input. Now let's see some tips for applying this allowance percentage. Don't apply percentage just randomly. Use data from some previous similar type of projects, some historical data you can get. Documents why you are including 5 or 10 percentage. Like you need to justify that percentage. You need to have some documentation for that. And always review and reduce allowances as the design progresses. So transparency is key. So as the design is getting matured, your allowances should reduce because you have a clearer scope of work, clearer design. So the allowances made should not be that high range. It could be a lesser one. So hope this short video was informative on what additional cost you need to apply while pricing. This is a basic video. You can utilize it when you have been asked a question in your interviews. And once you start getting involved in the pricing part of your projects, you'll easily understand what percentage would be better for what kind of project, what complexity, and when to apply. All these things will be clearer only with experience. So thanks a lot for watching this video. If you have liked it, do like it. If share it with your friends who are into the QS field. Keep watching Quantity Surveying Studio. Take care. Bye.
Hey everyone, welcome back to Quantity Surveying Studio. In this video, we're going to clear up a common confusion in the construction industry. That is the difference between an RFI, RFP, and RFQ. These three terms may sound similar, but they serve very different purposes on a project. So let's break them down. RFI, request for information. Let's start with RFI. So a request for information is used when there is ambiguities or missing information in the drawings, specification, or the BOQ. It is typically raised by the contractor to the consultant or client to clarify the doubts. Example could be, please confirm if a fire rated duct is required in the zone as the drawing doesn't mention it. Something like that. And it is definitely used both during the tendering stage and the execution stage. So while we are doing your takeoff from the drawings or making the BOQs in the tender stage, there might be a lot of informations required. There might not be some legends, symbols. Some symbols legend might be missing, or some pipe sizes or duct sizes might be missing. Some drawings itself might be missing. So all these could be raised during that tendering stage, and in the execution stage again, while carrying out the execution, there might be some doubts regarding whether a particular item is required or not required in a particular area or not. So these are cleared using a RFI, that is request for information. Next is the RFP, request for proposal. This is issued when a client wants vendors or contractors to submit a detailed proposal for a project. So this detail will include the technical approach, the methodology, the timelines, the experience of the team, and the preliminary pricing or the pricing breakdowns. So it should be a detailed one with specification. It's completely a detailed one. It could be of a specialist item. So sometimes an example is to submit a proposal for providing the MEP design and build services for a data center. So it is usually part of the procurement or pre-award stage. So like a specialized item or a specialized part of the work will be required from a specialist. So that for that purpose, an RFP is requested, and this is kind of, it will be completely in detail, complete design, execution, all the elements that is required to complete the project needs to be included in this RFP. Next is the request for quotation. This is basically used to get cost estimate or prices for specific packages, services, or materials. It is typically more straightforward than an RFP. So here we do not need any detailed requirements. Only the price. Main requirement is the price code for supply and installation of a 200 HDPE pipe, that is maybe for 500 meter length, and it is usually done using you during the procurement or during the post contract stage. Sometimes while your project is going on, there might be shortage of pipes, so you will have to request for a quotation from a particular supplier for a HTP pipe for 500 meters. So for that, a quotation is requested from maybe three finalized suppliers, some good suppliers in the market, and from them, whoever is quoting the best price, the procurement team will get the material from them. The difference between RFQ and RFP is RFQ is not a detailed one, but RFP is a detailed proposal, including all the requirements. This is just a quick comparison of RFI, RFP, and RFQ. As already mentioned, RFI is used to clarify information. RFP is for detailed proposal, and RFQ is for just getting the pricing. It is raised, RFI is raised by a contractor or a QS. RFP again is raised by a client or consultant, and RFQ is raised by a consultant or contractor. RFI responded by the consultants or designers, RFP by the vendors or the contractors, again RFQ by vendors or suppliers. And where it is used, RFI is used in the design, tender, execution stage, all the stages equally. RFP in the pre-contract and procurement stage, and RFQ usually during the procurement and the post-contract stage. So let's move into a conclusion. So you might have now understood what the difference is between RFI and RFP and RFQ. RFI is to clarify information, RFP is requesting detailed proposal, RFQ is requesting pricing, and each plays a unique role in the construction project lifecycle. So if this has cleared up your doubts, don't forget to like the video, subscribe to the channel, and hit the bell icon for updates. And if you have more such terms you would like me to explain, drop them in the comments below. Thanks.
Hi all, welcome to the Conti Surveying Studio. In this video, we'll be looking into 5 things to know before becoming a quantity surveyor. So if you're thinking of becoming a QS, this video could save you years of trial and error. QS is not just about numbers. Most people think QS is only about max and measurements, but in reality, you will be dealing with contracts, legal clauses, procurement strategies, and even dispute resolution. Soft skills like negotiation, communication, and managing stakeholders are also equally important. So as a QS, depending upon for which type of firm you're working, you will be communicating with a lot of stakeholders. If you're a main contractor, you will be communicating with the consultant, the subcontractor. If you are a consultant, you will be communicating with the client and then the main contractor, because you will have to certify the payments and advise the client. So depending upon which company you're working, like which stakeholder are you working for, is it a subcontractor, contractor, consultant, client, the communication is the main key. Drawings change a lot. Design changes are inevitable, especially in the early stages. So you need to be prepared for remeasurements, BOQ revisions, and explaining the cost impacts to clients. And hence you need to be calm and adapt quickly, something that you can never ignore. Right now also, I've been facing all these changes every day, like almost every week, not day. Like I'll be doing a takeoff from a drawing, and the next week revisions for that drawing come. Sometimes based on the designer, they might cloud whatever changes they have made, but sometimes designers don't do the clouding. So it kind of becomes a rework, and later on in each stages we need to explain to the client about why the changes happened, why the costing got impacted, why a particular system price got increased or decreased from
comparing it with the previous stage. So as the design matures, the cost also gets matures, and these needs to be explained clearly to the client. Playing with the drawings, that is one of the most important jobs of a QS. You need to be really specific in terms of the changes, and you need to explain it properly to the client. Site knowledge is gold. Even if you are mostly an office based QS, understanding the site condition is very crucial. A QS who can visualize how work is executed on site is 10 times more efficient in estimating and variation claims. So this is something, if you've seen my past videos, this is something that I always advise. If you are someone who's starting to start a career in the QS, first try to become a site QS. Move into the post contract, understand how the site works, see the different items that are being documented as a BOQ. So once you see all those items, then you'll always have that visualization in your mind, and later on in a different stage of your career, when you move into the consultant side, more of an office based job, it will be easy for you to prepare BOQs, do the takeoffs, and explain things to the client. So I would say the first 5 years you need to be at site, and then depending upon your interest, if you would love to be into the post contracts throughout your career, well and good. Or else if you think that, oh, you need to have some work life balance, you need to spend some time with your family, the Monday to Friday job is required, so then you need to move, you can easily move into the consultant side because you already have the site experience. I know a lot of freshers who gets recruited by consultants directly, and they start their jobs into the office, and it is kind of relaxed. And so once they get relaxed with that job environment, they would never would like to move into the site. They would definitely, once after moving, if they get an opportunity, they would feel that this is terrible because they had a good time in office, and now they would not be wanting to move into the side. But this is not going to be, I believe, that not going to be helpful in your long term career, because in your CV, yes, definitely the interviewer will come to know that you don't have any site experience, and that could be a black mark. Digital skills will set you apart. So tools like CostX, Cato, Candy, Bluebeam, Power BI, and even AI assistants are becoming very standard. So the QS who can combine technical knowledge with digital efficiency will always be in demand. In my day-to-day job also, I think I daily use AI tools like ChatGPT or Copilot for any technical doubts I have, or anything related to my work. Even for drafting emails, I use these tools, and it is making a lot of things easier. You need not wait to ask to your seniors or someone else, because again, that is kind of wasting time. You need to wait when they would be free. So now you have AI, everything can be got or from these AI tools easily. You can get the best result out of these AI tools, which makes your work also efficient. It's a global profession, so skills that you gain can be applied in the UK, Middle East, Australia, Ireland, and more. But each region will have their own measurement standards, the contract types, and work culture. So you need to keep learning. Continuous learning is the key. So depending upon, like, you need to understand the different standard method of measurements, NRM, POMI, master format, ARMs. This, depending upon the country, these standards are used in each country separately. If you're in India, usually a standard is not really used. So when you move into another country, there will be a proper standard, a structure is there. So you need to understand, go through it, and then start building your BOQs. So that is really important. So again, learning is the key. That's the main important thing. The final thoughts would be, knowing these points earlier could really help you speed up your career growth. You need to be adaptable, and you need to keep learning and embrace digital tools. So let me know, like, which of these points you resonated with you the most, or any points that surprise you? Like if you are someone who's planning to move into QS, you never knew any of these points was really important as a QS to know. Let me know in the comments box. Thanks a lot for watching this video. If you're not yet subscribed to Quantity Surveying Studio, please do subscribe. Take care. Bye.
Hi, welcome to the Conti Surveying Studio. In this session, we will look at the most common mistakes that occur in an MEP BOQ and how you can avoid them. So let's start this video. So let's look into the first mistake, which is the incomplete scope coverage. So sometimes during your BOQ preparation, some systems might be not provided, like the BMS, ELV, or some special system. So this would be really required for that project, but sometimes the design would not have been made or the design would have not been started. As a QS, we need to confirm whether this system is actually required or not. Because if we completely avoid that system, then we are avoiding the pricing of that system, and during the post contract stage there will be a lot of variations and claims going to be happening. So this will be leading to a variation claims later during the post contract stage. So solution is to cross check with the design drawing and specification to ensure that all the systems are included. Just for safety, just some common systems you can send to the designer as an RFI while preparing the BOQ. During that stage, you can confirm with them asking if this system is required or not, and sometimes they would confirm that the system is not required, sometimes they would confirm that this is required, and maybe design would be done at a later stage. Next mistake is the improper classification of items, that is mixing the supply items with the installation work can cause confusion. Sometimes some items would be just for supply, some items will be just installation. Supply will be done by the client or a specialist. Sometimes only supply we need to do as a contractor, and installation will be done by some other subcontractor. So that also we need to confirm. Incorrect work sections will be allocated, which can lead to pricing disputes at a later stage. So for that we need to follow a proper measurement rules like NRM2, POMI, ARM, where you have sections wherein if it is supplied by client, it can be mentioned in a different section. If it is just insulation, you can mention it separately. Maybe in the brackets you can mention it separately, or as a separate heading you can mention. So it is clear in the BOQ that we need to price only for the supply or just the installation. Next is not including ancillaries and supports. So excluding some brackets, essential items like brackets, hangers, fasteners, and controls. This can also lead to some dispute during the post contract stage, and contractor can claim them separately. The solution will be to ensure that ancillaries are included in the BOQ description, or as a separate system price we can add a line item for these ancillaries and support, so that the subcontractor can price it accordingly. Or else, as per NRM, all the supports and everything is included with the system. So in the description you can mention that it is supply and installation of such and such item, including all the required ancillaries and supports. So it is clearly mentioned so that there will not be a dispute, and the pricing is done including these ancillaries and supports. Next is wrong quantification, which is just a general mistake. There can be a error during your measurements, cable length, duct areas, pipe runs. Just the manual calculations can, as a human being, we are prone to mistakes. And some solution is to use digital to takeoff tools like CostX, Bluebeam, Revit, PlanSwift, and double check the quantities ourselves, and also let someone a peer review is also important, so that sometimes we would have missed out some items, even the countable items. Sometimes there are chances of us missing out, so that using these digital tools, it is easy for another person to go through and
check if we have missed out any item. Sometimes we would have completely missed out a drawing. So these things, the proper review is required, and uh, some mistakes which we cannot find out, our colleagues or the person who is reviewing our BOQ can find out. So that is one of the solutions that we can do to avoid these wrong quantification. Next is vague descriptions. Again, sometimes generic BOQ descriptions without specifications are provided, and ambiguities allows the contractor to exploit some loopholes during the post-contract stage. The solution can be to provide detailed description and also refer to drawings and specs. So it is always, if you've seen my previous videos, I've always mentioned that when you make a description at the end, mention that all according to the drawing number. If possible, if there are not much drawings, you can mention drawing number, or sometimes some system will be having a drawing one type of, you know, M, like M will be for mechanical, S will be for something else like that. Or else we can mention, if it is less drawings, you can mention as per drawing number such and such, and specification. You can also mention the specification document name, so that it is clear that we have gone, you should be referring to these drawings and specification to do your pricing. So if you don't mention that, the contractor can tell that, okay, you have not mentioned that it is as per this drawing and specification, so we didn't go through it. So we need more pricing, or we need more quantity, or more price for this item, more rate will be there for this item. So such things can be avoided. So the conclusion is, avoiding these mistakes will reduce disputes, variations, and cost overruns. And a well prepared BOQ always ensures fair competition and smoother project delivery. Thanks for watching. Don't forget to subscribe to Conti Surveying Studio. This is not just for an MEP BOQ, for any BOQ, civil, architectural, structural, any kind of BOQ. These are some general mistakes that could happen while preparing a BOQ. So, if you have found it to be useful, do like it and do subscribe to Conti Surveying Studio. Thank you.
Hi, welcome to the Conti Surveying Studio. In this video, we'll be looking into the top 5 FIDIC clauses that every QS must understand and should always have in their mind while doing their quantity surveying tasks. So without further delay, let's move into this video. The first one is regarding variations and adjustments, which is clause 13. So this is mainly where the engineer will have the provisions to instruct changes, additions, omissions, substitutions, sequence adjustments, etc. So accordingly, the QS has to measure these additions or omissions and do the rate analysis using the contract rates or new rates. The contractual rates means there might be already some appendix wherein the items already existing for that project, the rates for these items is already available, maybe in the BOQ or the pricing schedule. Or else if it is completely a new item, then you have to do a completely new rate analysis to work out the new rates. The impact is mainly affecting the project cost and tender adjustment. So accordingly, the project cost will increase or decrease based on how you have arrived to these rates and how you have claimed these items. One example is like the BOQ will be having 100-meter drainage pipes. So as per the instructions from the engineer, some new area, there might be requirement for putting some extra 50 meters, and depending upon that instruction, the QS will prepare a variation order. They will do the rate analysis. Since it is the BOQ, there is already this item available. The rates can be directly used for these extra 50 meters. So if you see in clause 13, variations and adjustment, these are some of the sub clauses. 13.1, right to vary, value engineering, variation procedures, payment in applicable currencies, provisional sums, day works, adjustment for changes in legislation, adjustment for changes in cost. So I'm not going into detail of each. You can just open the FIDIC, maybe Red Book, and go through these sub clauses. Next one is clause 20, which is regarding to the claims, disputes, and arbitration, where there are some procedures on how you should submit a claim. There are some time limit for this is around 28 days after becoming aware of this claims, and if you don't submit it within this time, you risk of losing the entitlement of getting that extra payment for these claims. The QS role obviously is to make a document substantiate how the claim has happened or how the delay has happened due to what reasons and what are your entitlement, your cost, extra cost that is involved for this extra claims, and all this needs to be maintained with strong background support or else it can be easily rejected. An example can be delay in drawing approval. So as per the original program, few drawings must be approved within this time period, but then there might be a delay in getting the drawings approval, or accordingly the works will also get delayed and the QS can submit the claims with the cost of idle labor and equipment due to this delay. So if you see the clause 20 subclauses, claims, disputes and arbitrations, we have the contractor's claim, appointment of the dispute adjudication board, failure to agree dispute to adjudication board. If any disagreements happen, some negotiations will happen. Sometimes this will be directed to the DAB, the dispute adjudication board, and accordingly there are different procedures for appointing it and how the final decision is made to close down that particular dispute. Obtaining the dispute adjudication board decision, amicable settlement, arbitration, and if at all there is no settlement happening for the dispute, it goes into arbitration. Again, how, what all are the procedures for arbitration, that is also mentioned under this subclause. Failure to comply with dispute adjudication board decision, expiry of dispute adjudication board's appointment. So all these subclauses can be again gone through under the FEDIC Red Book. You just go through it. Next is the clause 14, which is contract price and payment. It defines the valuation of works, how you can claim for your works done, interim and final payments, advance payments, retentions. Every month you will have to get your payment certified by the consultant or the main contractor. So how you need to prepare the invoices for that, what all should be the backup documents, all these are coming under this clause. The employer must pay the certified amount within, again there is a timeline wherein the employer should be paying. That is also part of delays. If at all the employer is not paying within that 28 days timeline, there are different clauses wherein you can get the interest for the delay days. The QS role again is to prepare the payment application according to the clauses and ensure the measured works and materials are included in these payment applications. The QS must be coordinating with the site team to understand what are the works that has been carried out in that particular month and make sure that everything is captured in your payments application that is prepared. Example, again, contractor applies $1 million as a payment and the engineer will certify as 950,000 K. Accordingly, sometimes the engineer will verify if all the items claimed has been correct or not, and then they should pay that 950K within that due period. So this is clause 14. So again, clause 40 subclauses, contractor price, advance payments, how you can make the advance payment claim or the amend application for advance payment, application for interim payment certificates, schedule of payments, plant and materials intended for work, issue of interim payment certificates, payment, delayed payments, payment of retention money. Around 5% of money will be deducted as retention money, and how finally it can be paid once the project is completed, and all those is under this clause. Statement at completion, application of the final payment certificate, the final closing out, then the discharge, issue of payment, final payment certificate, cessation of employer's liability, currency of payments. All these are under this main clauses 14, contractor price and payment. Next one is the clause 8, commencement, delays and suspension. So here under this clause, it defines when is the start date of the project, when is the completion deadline, the EOT, extension of time rights if delay is not contractor's fault. Again, it includes suspension of work if instructed due to different various reasons. The QS role is to work with the planner to prove the cause of delay. Using the critical path analysis method, you can work out this delay and the prolongation cause can be worked out according to this critical path analysis. So again, example is site possession is delayed by 2 weeks. QS needs to claim for that 2 weeks extension of time plus preliminaries, because a lot of things are getting idle, and again due to this delay the completion date is also getting delayed. So that is not the problem of the contractor, because site possession is the client's or the employer's duty to provide the site possession the correct time. So you, as a contractor, you can claim for the delays. So clause 8, commencement of delays and suspension, we have the sub clauses: commencement of work, time for completion, program extension for time of completion, delayed caused by authorities, rate of progress, delay damages, suspension of work, consequences of suspension, payment of for plants and materials in event of suspension, prolonged suspension, resumption of work. So all these sub clauses are under this clause 8. You can again go through it. Now the last and final one, which is important as a QS, would be the contractor's general obligation. So this clause will lay down the execution requirements, specification, safety, compliance that needs to be properly followed for completion of the project. So again, in design and build projects, the design responsibility will also be under the contractor, so that also will be mentioned. The QS role will be to check if what is the scope, whether it lies within the contractor or employer when evaluating claims. Example will be contractor claiming scaffolding for other trade as extra, but clause 4 will show that obligation is contractor. So providing scaffolding for all the works is part of the contractor. So the consultant might reject this claim because as per the contract's of general obligation, as per that, scaffolding in general is their scope, and it is their responsibility to provide the proper cost for the scaffolding works throughout the project. And if they are claiming it as additional, it is not right, because they have already claimed it in there, or they have already priced it in their preliminaries for as scaffolding charges. The QS can reject this claim. If you see clause for a lot of sub clauses: contractors general obligation, performance security, contractors representative, subcontractors, assignment of benefit and subcontract, cooperation, setting out safety procedures, quality assurance, site data, sufficiency of accepted contractor amount, unforeseeable physical conditions, rights of way and facilities, avoidance of interference, access route, transport of goods, contractors' equipment, protection of environment, electricity, water and gas, employers' equipment and free issue material, progress report, security of the site, contractors' operation on site, forces. Quick recap: the top 5 FIDIC clauses: clause 13, 20, 14, 8 and 4. So 13 is variations and adjustments, 20 is claims, disputes and arbitration, 14 is contract price and payment, 8 is commencement, delays and suspension, and clause 4 is about contractor's obligation. I know this is not like a detailed video on this for 5 clauses. There's nothing to teach you or explain in detail. Just going through those sub clauses, you can easily understand what each sub clause means. I'm just pointing out which are the main sub clauses, like the main clauses. As a QS, these are the main thing that you might be asked in an interview when you are applying for a contract administration or maybe a post contract QS roles. It is an important for someone doing that role to know these basic clauses, so that the interviewer is happy, or the head of that project is happy that okay, this QS understands the basic clauses that is required to safeguard our risks as a main contractor for all the payments, all the variations, etc. So thanks a lot for watching this video. If you found it to be useful, do share it with your QS fraternity, QS friends, QS connections. Please do subscribe to QS Quantity Surveying Studio if you're not yet subscribed to it. Thank you. Bye.
Many professionals use the term contract administration and contract management interchangeably, but in construction projects, they mean two different responsibilities. Understanding this difference is critical for quantity surveyors and commercial professionals. The simplest way to remember the difference is this: contract administration is about following the contract, and contract management is about managing performance under the contract. Both work together, but their focus is not the same. Contract administration deals with the day to day contractual procedures of a project. It focuses on ensuring that the contract terms are applied correctly and fairly. This includes issuing instructions, managing variations, certifying payments, assessing the extension of time claims, and administrating completion and defects. Whereas contract management is more strategic and commercially focused. It looks at how the project is performing in terms of cost, cash flow, and risk. This includes cost control, forecasting, cash flow planning, risk management, and claim strategy. The aim is to protect value and minimize commercial risk. Now let's look at a simple example: late issue of drawings. From a contractor administration point of view, the focus is on assessing whether an extension of time is due. And from a contract management point of view, the focus is on cost impact, the mitigation measures, and protecting the project budget. So, for the same event, there are two different responsibilities. Now, who performs these roles? Contract administration is usually carried out by the architect, the engineers, or a QS, depending upon the form of contract. And contract management is typically handled by quantity surveyors or commercial managers. On very small projects, one person may perform both the roles. In summary, good contract administration keeps the project contractually compliant, and good contract management keeps the project commercially healthy. So, to be an effective quantity surveyor, you need to understand and apply both